Hello, I have a couple more problems from this time section 6.6, and they're logarithmic equations. And first one is number 28, and we're having to solve a logarithmic equation with two logarithms on one side and equals a standalone number, which is 3 on this side. And how to do this problem here is you've got to write the left-hand side as a single logarithm. And you do that by the product rule, which is what we just learned about in 6.5. And as a matter of fact, I just did a problem on this video clip with 6.5 just previously. So you have to write this as a single logarithm. So this becomes the log base 2 of the product x times x minus 7 equals 3. So remember, the sum of two logs is the log of the product. So then you have to change the logarithmic equation to an exponential equation by its definition. To do that, the base is 2. So remember now, the input of the exponent is the output of the log. Well, the output of the log is 3. The log of this equals 3. So if the base is 2, this is now exponential, and its input, its exponent, was the output up there. So it's 2 to the third equals, now the output of the exponent, exponential, is the input of the log. Well, the input of log is this expression right here. So in essence, what you're doing is saying 2 to the third equals this. So that's how you change it to exponential form. So 2 to the third is x times x minus 7. And at first glance, you're like, this is going to be kind of a tough problem. Well, it's not too bad. It's quadratic. 2 to the third is 8. And that's x squared minus 7x, distributing the x. And since you got quadratic, you can set it equals 0. Probably the easiest way to do this is just go ahead and move the 8 to the right-hand side. So it's x squared minus 7x minus 8 equals 0. And this actually is friendly because it's factorable. If it wasn't factorable, then we'd have to use a quadratic formula. And that's what I call an unfriendly problem. So this is x minus 8 times x plus 1 equals 0. And so x equals 8 and x equals negative 1. Now, some people, when they get to this point right here, they think, oh, great, they got two nice numbers. They got to be right. Here's where you got to be careful, because the problem has logarithms to begin with. And when you have logarithms, the answers that you might get end up, that makes it undefined, because remember, you cannot take the log of a negative number. Now, 8, I think, is okay, because you can take the log base 2 of 8. You can take the log base 2 of 8 minus 7, because 8 minus 7 is only 1, and 1 is positive. So you would be able to get 3 off of this one. However, the negative 1 would create an issue. Log base 2 of negative 1 is undefined, because remember that when you're doing this, the input has to be greater than, or just greater than 0. Okay, so that doesn't necessarily mean negative numbers are not allowed every time, because when you put negative numbers in there, sometimes if it works out for you that you put a negative number in, it turns out that the expression turns out to be a positive number, and that'd be okay. So you just can't just discard the negative numbers just because they're negative. You got to make sure that when you put the number back in, the domain becomes a negative number, and then you can say, okay, then it doesn't work. Now, as far as this other problem, this is an exponential equation, a little tougher than number 28 is anyway. And remember, this is not 28 and 48% in the book. These are just kind of problems that I tweaked them a little bit, and they look a little differently. So this one we're going to solve for x. And now the homework, they want you to change it to a decimal. And I don't have a calculator up here, so I'm not going to get the decimal for you. I'm going to leave that up to you. But I can solve for x. And the way you do that is, if you're trying to solve for x and they're both in the exponent, the way to do this is to be able to bring the exponent down. And just in the recent past, you've probably learned the only way you're going to bring something down is if you can use the power rule. So what I'm going to do is I'm going to take the natural log of both sides. Because whatever you do to one side, you have to do it to the other side. But by the power rule of logarithms, remember the exponents get to come down. So x minus 1 times the natural log of e equals x times the natural log of pi. Now remember, the natural log of e is 1. It's one of your basic properties of logarithms. So you end up with x minus 1 equals x times the natural log of pi. And like I did a problem a while ago with this one, I had x's on both sides. This has an x. This is kind of what I was doing with the inverse functions. This x right here and this x right here has to be paired off. and a minus 1 doesn't have one. So what I'm going to do is play musical chairs with these two terms right here. So this is going to be x minus x times the natural log pi. That's actually a pi right there, not natural log of x. So it should be a natural log of pi. So x minus x natural log of pi equals to 1. So in essence, I just played musical chairs with these two terms right here. Then factor the x out. Be 1 minus the natural log of pi equals to 1. So I factor the x out. And you might want to check that to make sure, because a lot of people make a mistake there, and it's a silly place to make a mistake. Just check your math. X times 1 is x times the natural log of pi is x natural log of pi. So it's an easy check. It takes about 2 seconds to check to make sure you didn't make a silly calculation. But I have found that a lot of students will make a mistake right there, and because they don't remember how to reverse distribute, basically. Factor out a monomial is what you're doing. So only thing left to do is get rid of the 1 minus pi. So divide it to the other side. So x is equals to 1 over 1 minus the natural log of pi. Yeah, it's ugly. Nothing the calculator can handle for you though. So, but it's 1 over 1 minus the natural log of pi. But whatever that numerical value is, it will be a decimal. That number, whatever it is, when you put it back in here for this x and for this x, it will be a decimal, and it will be an ugly decimal, but the left-hand side should equal to the right-hand side. This does not have logarithms in the original equation, so unlike this problem over here a while ago when x equals -1 was disallowed, this thing will accept anything. There was no logs in the original problem. Now remember on number 28 over there, that number was disallowed, so it's only 8. 8 is the only solution. But on this one, I don't even need to check it. I mean, as a matter of fact, if you try to check this back into the original problem, you're bound to make a mistake. You better make sure your work is correct along the way. Because here, checking is definitely more difficult than solving the problem itself. You've always been taught, check your answer, check your answer. Well, that's at the lower level stuff. At the upper level stuff where you're at right now, checking is probably not the way to go. I mean, because you have to put that back into here and then subtract 1, take e to that power. Calculators won't be so bad, but still, just make sure your work is correct and you won't have to do anything there. But that's it.